Well, congratulations, guys. We are on the last podcast of Unit 1. So
Yeah.
you guys have stuck with us this whole time, and that's wonderful. So,
Yay.
so podcast or Vodcast 1.9, we're going to continue with our dimensional analysis discussion. We need to talk about multi-dimensional problems and cubic and squared problems.
Yeah. So it's the same process, guys.
Yeah, so here's our rules.
Here we go.
Same exact rules.
Yep.
It gets a little
Nothing's
more
changed.
complex because now we're working with multiple dimensions.
Right. So instead of just starting with something in the numerator over 1, it's going to be something in the numerator and the denominator.
Yep. Okay. So the key to multidimensional problems, the key to multidimensional problems is to do one dimension
At a time.
at a time.
So work on the top dimension first, and then work on the bottom dimension.
So let's do an example here.
Okay.
So here's
that you?
Mr. Sam's. Yep, or Mr. Sam's. This
That's
is
not
Mr.
me.
Not you. This is me, Mr.
That's
Bergman.
Mr. Bergman.
And I am traveling very rapidly in a triathlon. So I'm in a triathlon right here. I don't know if that's rapidly. And I am in my cool tight skin suit, racing for my life, so to speak. This a couple years ago. And let's just see. All right, now here is some stuff. I keep track of my workouts like with a GPS device. And this is a ride I did on July the 7th of 2008, so last summer. And I started at 6:14 in the morning. Nice, good early morning.
Let's see, July 7th, 6/4. That's my son's birthday. I probably got up at about 7.
And basically, I traveled a pretty fair distance. I traveled 100.08 miles.
Wow.
Yeah, it took me 5 hours and 49 minutes. And while you're at it, just as a note here, speaking of quantitative data here, this was my elevation profile right here. Ooh, and there's the high point, and then bump, 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 and then back here. And so I started here. This is Colorado Springs, Colorado. For those of you who are Colorado Springs people, understand the whole idea here. And I started, looks like I pretty much went south. And then I went out way the heck out, and then I went up past near Ellicott, turned back, and then I turned on this road, and eventually made my way back to, I think I pretty much probably started in Manitou Springs, actually. Yeah, no, it looks like,
No, you're.
no, I think I'm at the
South
Home
End.
Depot. I bet I
Yeah.
started at the Home Depot right there. And so anyways, so we're going to do some math with this. Now, something you can notice here, my average speed for 100 miles on a bicycle was 17.2 miles per hour. So let's do a problem with that. We've got some conversion factors here. So let's say that I started at 17.2. Now,
Miles per hour. That's the number of miles you went in 1 hour.
all right, miles per 1 hour.
Right. Now, because miles per hour is miles over hours. Never keep the units, a complex unit, in the numerator together. Always split it up.
What I often see students do is they'll write 17.2 miles slashy hour. There are
Oh,
no
slashies.
slashies. Do not do the slashy thing. So what I want to do, actually we haven't asked what the question is, I want to convert this to meters per second. I have a slashy, I know, but I want to convert it to meters per second. So what I'm going to do is I'm just going to do a fraction, and I'm just going to do the math here.
Yeah.
So if I do miles,
But I don't know the conversion from miles per hour to meters per second.
I don't either. So I'm going to go from, I'm going to ignore hour for just a moment. Leave it right there. I'm going to go from miles, and I'm going to go to something. How am I going to go miles?
Can we go miles to meters?
Well,
Do
let's
we
see.
have that?
No, I've got miles to
Miles
kilometers.
to kilometers, or we can go miles to feet, and then no, miles to kilometers. And yeah, let's go miles to kilometers.
So
Yeah.
actually, I'm going to go from miles to kilometers,
Yep,
and
and then
kilometers to
kilometers to
meters. Let's kind of make a little road map.
Okay.
So I can go miles to kilometers. Now let's go back and look at the number on the chart here.
1.609.
There's 1.609 kilometers in 1 mile.
Okay.
My miles cancel. And now I just keep on going on my
Right.
fraction.
Now, we can go kilometers to meters. That's easy.
I can go kilometers to meters. Now that's
Yeah.
not on my conversion
No,
table. So if I
that's
go
a
back
metric
to the
thing.
conversion table, no kilometers to meter.
No.
You're going to have to use the fact that
1,000 meters.
there's 1,000 meters
In
in
1
kilometer.
kilometer.
And the kilometer cancels.
All right, now I'm in meters on the top.
That's what I want. I want
Yeah.
meters on top,
That's
and I want
good.
seconds on the
So
bottom.
meters per hour, but that's not what we want. We want
Meters per second.
per second. So we need that hour to turn into
So
something
I
else.
just keep going. I don't
Yeah.
stop. And I see out. Now, this is something before this moment, whenever we've
Yes.
done a problem, we've always canceled by putting a number on the bottom. We're going to put a number on the top because the rule isn't bottom,
It's opposite.
opposite. So ours is on the bottom, and I'm going to put
Hours
minutes.
to minute.
And of course, 1 hour, there are 60 minutes. Don't mix that up, by the way. It's easy to sometimes think there's 60 hours in a
Now,
minute.
some people panic at this point because they don't want to cancel things out that aren't touching, but that's okay.
The hours is on the bottom.
Right.
The hours is on the top.
It doesn't matter where they are in the problem.
That's correct.
You can cancel a top to a bottom anywhere in the problem.
And now I do one more again, and I will
Yes.
just say I have the minutes on the bottom. I'll put minutes on the top, and I'll put seconds on the bottom. There is 60 seconds in 1 minute.
You
Now
almost
this
put
is
60 minutes in 1 second.
I know I didn't do it.
saw it.
I was testing you.
Yeah.
All right, now this is an interesting problem because we have 3 numbers on the top and 2 on the bottom. The bottom ones are divide.
Yep.
The top ones are time. So,
Yeah.
Mr. Sams, you got the
I will
calculator?
punch in the calculator. Why don't you cancel those units out while I do that? I got 17.2 times 1.609
Times 1,000.
times 1,000 divided by 60 divided by 60. Anything in the top gets a times, anything in the bottom gets a divided. Enter. 7, well, how many sig figs do we want?
3
3. So I got 7.69
meters per second.
meters per second.
So on average, you know, as going uphill, I would go slower and downhill faster. On average, on that bicycle, I was traveling 7.69 meters every second. So that's pretty fast, actually.
Yeah.
For 100 miles.
Yeah.
In big races, I'll try and travel 21, 22 miles an hour.
Wow.
But on training rides, you can't ever do that, especially with that elevation profile. Oh my gosh. Yeah, most races aren't quite that hard. All right, let's do another one. Okay. Now this is, by the way, a sample of gold over here. So gold has a density of 19.3 grams per milliliter. So 19.3 grams. No slashies over 1 milliliter. Now, our problems will have slashies,
Yeah.
but
You
need
have
to
to
write
unslashy them.
Unslashy them. That's a good way.
Unslashy.
So I need to convert
Your
grams
thermometer.
to pounds and milliliters to liter.
Oh, yeah.
So basically, if I had a liter of gold, like a liter bottle of pop, not a 2 liter, half of one
Right.
of those, right? How much would it weigh in pounds? It'd be an interesting question,
You
actually.
got an Nalgene bottle, that's 1 liter. That's a lot of gold.
That'd be, well, let's see
How
how,
much
much
that
it weighs.
would- how much would that
We'll
weigh?
find out.
Yeah.
All right, so 19.3 grams per 1 milliliter.
All
Let's
right.
do the
I know-
mass first.
Okay.
So I got a G on the top, so
Yep.
I'll put a G on the bottom.
Yep.
I'm going to go pound.
Yeah.
Now, we've got to look at our
To our
conversion
table.
table.
Somewhere.
Forward to
Where
our
did we put
conversion. There it is.
is.
Pounds to grams. That's that 454 number. I guess,
454
right?
grams in 1 pound.
So there's 454 grams in 1 pound.
Okay,
The G's
so
cancel.
we're in
Well,
pounds.
we got pounds per milliliter.
Pounds per milliliter. We don't want pounds per milliliter. We want pounds per liter.
Now the milliliters on the bottom. Rule goes on that
Top.
and then
Liter.
There's 1,000.
1,000.
Now you got to know that. If you don't know that, you got to figure that out. And the milliliters cancel.
Yep.
So Mr. Sams, what do we come up with there?
19.3
Divided by.
divided by 454 times 1,000.
What do you get?
42.5.
42.5 pounds per liter.
That's
Wow.
My son weighs about 42 pounds.
He's not a liter. He's a lot
No,
bigger
he's a
than
lot
liter.
bigger than that.
But gold is one of the most dense things that exists, so this
Yeah.
is not totally surprising to me. So a liter of gold would weigh 42 pounds. -ish.
Wow.
That's a lot.
That is.
That's quite a bit. Okay, a couple more examples here. All right, 44 centimeters cubed to inches. Now we need to kind of talk
Yeah.
this through.
Now, this is not a slashy split it up thing.
yeah,
This is.
hard.
No.
Oh, all right.
It's not hard.
All right, now here I want to show you something. What is a centimeter cubed?
That's a centimeter times centimeter times centimeter.
Right, it's a box, right?
Right.
That's a centimeter by centimeter by centimeter, right?
Yeah.
And so instead of writing it centimeter cubed, I'm going to say cm, cm, cm.
Which is the same thing. We just expanded it out a little bit.
Yeah, it's the expando version.
Expando.
So
No
now-
slashies and expando.
So now I just need to convert centimeters to inches 3 times.
3 times, yeah.
So if we look at our conversion table, centimeters to inches. Here it is. 2.54 centimeters is 1 inch. So what I'm going to do is I'm going to put centimeters to inch. And we know there's 2.54 centimeters in 1 inch.
Okay.
Crosses off center. Now,
Oh.
am I done?
No, you got 2 more centimeters.
I've
to
got
get
to
rid of.
cancel out all 3 centimeters. I have to do this 3 times. So I'll say 2.54 centimeters is 1 inch.
So we're converting centimeters cubed to inches cubed, which is saying centimeter, centimeter, centimeter to inch.
Inch. Kind of like, yeah. Isn't there some kind of story about that?
There is.
Foot.
Yeah, foot. There's a rabbit. 3 rabbits. Ask me in class. I'll
Okay.
tell you the foot story.
So now I'm then with inch, which is an inch cubed. So
Yes.
now I'm going to take 44.
44.
Divided by.
Divided by.
2.54.
2.54.
Divided by.
Divided by.
2.54.
2.54.
Divided by.
Divided.
2.54.
1,
Equals.
2, 3, got 'em. 2.69.
2.69.
My calculator says 2.68504474.
That's not right. 44 divided by 2
Oh.
divided by 2 divided by 2.
Yeah, 44 divided
Oh,
by
that sounds right.
2.54.
Okay.
Yeah.
And that'll be inches
Oh,
cubed.
but we only want 2 sig figs.
So we'll say
44.
2.7 inches cubed.
Yep.
Okay. All right. All right. Let's do another one. How
Yeah.
about foot cubed to micrometers?
Micrometers. cubed.
Micrometers
Wow.
cubed. Oh my.
Okay.
All right. 0.
It's not hard, it's just-
0.0065 feet,
Foot.
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 Now
He's gonna have to write small.
I need to convert feet to
Feet to
centimeters.
Yeah, feet to centimeters, and then centimeters to
Meters.
probably meters, and then meters to micrometers. You could probably go centimeters to micrometers, but I don't know what that conversion is.
I can't do it with that one. No, I don't
No.
know that. So foot. So I want to go from foot to centimeter.
Okay.
Now we have that
We
conversion
do. It's 30
somewhere.
point something.
Yeah, 30.48 inches.
In 1 foot? That's not right. 34.48 centimeters. That's incorrect. We need to fix that.
Yeah, we got to fix our tear. That's centimeters.
Yep.
Okay. All right, that's good.
I'm gonna make myself a note.
We'll do it right now. 1 foot is 1 foot. Is 30.48 centimeters. Now I've got to do this 3 times,
Yep.
right? 30.48 centimeters in 1 foot. 30.48 centimeters in 1 foot. So my foot cancels.
Foot.
Foot.
Now we're
Now.
in centimeter.
Now I'm going to do centimeters to meters.
Right.
Now, what's that?
Well, there's 100 centimeters in 1 meter.
Yeah, you got to know what centa means. Centa means 1/100.
Like cents. There's 100 cents in a dollar.
That's right. I'm going to try and fit this in the first line, and 100 centimeters. Okay. Now my centimeters cancel. This is a long problem. Mr. Bergman picked this.
Yeah.
Okay. And then we still got to keep going.
We're gonna bring it down here a little bit.
And so now I want to go to micrometers. So
Yep,
I have
so
meters on the
meters to
top.
micrometers.
So meters to micrometers. And there's 1,000,000 or 10 to the 6th micrometers in a meter. Now how do I know that? There's that conversion.
It's on the table, the metric
on the
table.
So 10 to the 6 micrometers in a meter. And lastly, 10 to the 6 micrometers in 1 meter. Now this one's going to be tricky on the calculator.
It is. I
Mr.
was just
Sims.
thinking of that, but I got it. I got to figure it
So 0.0065.
out. Okay.
Watch him as he types this in.
0.0065
Times 30.48 times 30.48 times 30.48 divided by 100 divided by 100 divided by 100 times. Now, this one, 10 to the 6th, is actually 1 times 10 to the 6th. So you're going
Right.
to type in 1e6, or double E, whatever, times 1e6 times 1e6 equals. Be a big number. I
Oops,
think.
I missed something. I typed an L for some reason. Hang on, just a minute.
Well, watch as he makes his
second
corrections.
EE. Oh, good grief! What am I doing? Sorry. Let's try this again. 1, second EE, 6. There we go. That's good. Okay, enter. How many sig figs do I want?
2.
1.8 E14.
Okay, and the units on that would be micrometer cubed.
Yep.
Wow. That makes sense.
You didn't finish canceling your units.
Oh, did I forget to cancel? Oh, my meters. I forgot to cancel my
Meter,
meter, and I got
goes
micrometer,
meter.
micrometer, which
Yep.
is micrometer cubed.
Yay.
All right. Boy,
All right.
that was ugly.
Ooh,
Oh!
Speaking of ugly,
Speaking of ugly, this is probably one of the classic ugly problems.
if you
Okay.
can do this, you can do anything.
Yes.
You are
So
super-
4.5, it's in slashy, so I'm going to write pound, no slashies.
No slashies.
Per 1 foot.
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 4.5 pounds per
Now
foot,
I got to
foot.
go from pounds to grams. I can
Okay,
do that.
that's an easy. That's a
just a
one-stepper.
one-stepper. So let's do that. Pound to gram. There's 454 grams in a pound.
Okay.
Pounds canceled. Now to get feet to centimeter.
We can go foot to
Oh, we got
centimeter,
the 30.
the 30.48.
Yeah, let's
we
use
used
that.
last time.
So
Okay.
actually, this isn't so bad.
No, that's easy.
You can say 1 foot is 30.48 centimeters.
That
right?
gets rid of one of the foots.
One of the foots goes away.
One of the feet? One of the foots.
I don't know.
I don't know either. But we're going to do it 3 times. 30.48 centimeters per foot.
Notice each
Foot.
time I write a number,
Foot.
I also write a unit.
Always.
Centimeters or foot. No naked
No
numbers.
naked numbers. We will look at you funny and say that is inappropriate for school if you show us
Well, that would be
naked numbers.
grams. I think I got it. Grams per cubic
Grams
centimeter.
per centimeter.
So on the calculator,
All right,
Sam,
here we go.
4.5
4.5
times 454
54.
divided by this 30.48 3 times. I bet you can figure that out.
30.48. 0.072
And that would be
grams
Grams
per
per
cubic centimeter.
centimeter cubed, which of course you can see in our wonderful box over here.
Yes. Do we have more?
I think we have.
Hey!
I think you've just finished the Unit 1 podcast, and you should be very happy.
Yay! You're now a dimensional analysis
Expert.
professional.
No doubt. All right.
Enjoy!
Bye.